Hi there, this is Rob from Auburn Amps, and today we are talking about tube rolling dual triode preamp tubes, 9-pin tubes that are commonly used in preamp positions and phase inverters, reverb drivers in most guitar amplifiers. I'll do another video for rolling output tubes, but right now we're going to focus on dual triode 9-pin tubes. Now, what does tube rolling mean? It means trying different tubes in your amp to either achieve a tonal goal or just to satisfy your curiosity. And in order to save you time, energy, and money, I'm going to give you some tips on how to go about doing this in the most efficient and worthwhile way, so you can draw some usable conclusions that will help you do what you need to and then get back to focusing on music. So one tip is fundamental, that you do tube rolling with a friend, someone to help you out. It's pointless to try to do it alone. Why? Because your tonal memory is too short. You have echoic memory of about 4 or 5 seconds. If you really focus on an oral memory, you might be able to stuff it into short-term memory, which lasts 20 to 30 seconds. It's not enough for you to change tubes, warm the other one up, and get back to playing and make a reliable assessment. Now, this is not meant to be a criticism of your ability to hear. It's true of everyone that we just don't have the oral memory, the sonic memory to carry this off by ourselves. Also, our expectations will color what we perceive. In other words, if you've bought a $200 NOS Telefunken tube, of course it's going to sound better than the one that's already in your amp, because you need it to, you expect it to, because you paid all that for it. If you think you're immune from these effects, I'm sorry, no human is. We just our perceptions are affected by our expectations. A physical example of this is when you step on or off an escalator that isn't moving. I think you know the effect I'm talking about. It's the same when you're listening for changes between tubes. It's better that you don't know anything about the tube that's in your amp. So the partner who's helping you should not just go back and forth between two tubes. For one thing, they need to label them something innocuous, A or B or P or Q, so you don't know which one they're referring to. Maybe they shouldn't know either. Wrap it in paper and just mark the outside. And instead of going back and forth, they should put the first one in several times in a row to test you, to see if you can reliably detect the difference. So that's the first test. You need to be able to say, this is tube A, this is tube A, and be right 90% of the time, or you're done. If you can't tell the difference between the two tubes, then as far as you're concerned, there is no difference, except maybe the cheaper one is a better choice for you. So those are the reasons you need a partner helping you do this. Now, there are two flavors of rolling tubes. One is to change the tube type, using a different type of tube in a socket in your amp. Now, you'll often see a chart showing the different gains of the various tube types. A 12AX7 is often shown as having a gain of 100. 5751 will be about 70. A 12AT7 is shown as having a gain of 60 generally. 12AY7 will be 45. A 12AU7, 19 or 18, and so on. But don't think of these as just interchangeable plug-in gain modules. Even though they are pin compatible and they will work in the amplifier, they are different tubes types with different characteristics. They ultimately should each be in a different circuit, in a circuit that's designed for them. So when you stick a different tube type than what that circuit was designed for in your amplifier, then you're not listening to that tube type. You're listening to how that tube type performs in a circuit designed for a different tube type. I hope I've made that clear enough. If you're sticking this in a V1 position of an amp that's normally got a 12AX7 in it, and you stick a 12AY7 in, and you think it sounds warmer, you can't conclude that the 12AY7 is a warmer tube in general than the 12AX7. all you can conclude is that you find that that tube sounds warmer than the previous tube in that position in that amp. And when we go out to the workshop and do a little hands-on stuff, you can actually see how the different tube types affect the bias point. Now regarding bias, most preamps are preamp tubes are cathode bias, which means the negative voltage required on the grid is actually achieved by current through the cathode resistor causing a positive voltage on the cathode, and so the grid is negative with respect to the cathode. There's no automatic self-biasing process with this type of circuit. All self-bias means is that the bias is provided by the current through the cathode resistor. Now, a 12A U7 is going to want ideally a different plate and cathode resistor in a circuit for a given plate voltage, a given B plus, I mean, than a 12A X7. But if you're tube rolling, then you're putting that 12A U7 in some unfamiliar territory. It's going to bias up very differently, and we'll see that outside. So they're not just plug-in gain modules. There's more to the picture than that, and you can't draw these conclusions about how an amp, how a tube sounds. You can't extrapolate conclusions from what you find. To give an example, say you're trying an old British Mullard in your V1 position compared to some inexpensive tube that's in there now that you're not crazy about, and you found that you really like the sound of the Mullard. You can consistently identify that is the tube that's in there, like your partner is labeled that tube B, and you can say, yes, I always like tube B, I can always hear when B is in there. Then you can conclude only that you prefer that sound from that tube in that amplifier at this time with this guitar. You can't conclude that British tubes are better than the other type that was in there. You can't conclude that old types are better than new types. Yet people will jump to these conclusions and share them online, but it's silly. And I'd like to sit some people down and show them that their prejudices cannot be substantiated in an actual double-blind test. Some people will find that they consistently like tubes that are very different from what they believe they will like. Anyway, this is all just intended not to make anyone feel stupid. It's to make people get back to playing and save some money and discover some things that will be useful in finding the sound they want. So let's go out to the workshop and do some hands-on tube rolling of both types and see what we see. Okay, welcome to my home workshop. What I've done is I've cobbled together a very simple representation of an extremely standard single triode stage. We have a 100K plate resistor, a 1.5K cathode resistor, a B plus of about 310 volts, and that's coming from a saggy power supply, a linear supply that's right off the line, which is a close representation of what you see in most tube guitar amplifiers. I've got some other meters connected up to this circuit for my own purposes. They're not on camera because that would just confuse things. What we're looking at on the voltmeter is the plate voltage of this triode circuit, and the B plus is about 310, 320. It bounces around because it's on the line, of course. And what's on the scope is just the output from the tube. We're using 440 hertz because we're musicians here. And what we're going to do is I'm first going to go through different tube types in the same circuit so you can see how the tube types are affected by a circuit that's designed for a different tube type, both in their gain and in their distortion characteristics. After that, I will go through a series of tubes that all came from the same batch. These are contemporary tubes, JJs in fact, and you'll get a sense of what the batch variation is in new tubes. Finally, I will go for a series of older tubes. These are used tubes, various countries, various ages, and you can see how their numbers will stack up and how their performance will stack up. It give you a sense of what kinds of things you will come across if you're tube rolling. Okay, what we're looking at now is a 12AX7 and ECC 83. We're seeing a B plus of a plate voltage of about 205 volts, and the cathode voltage is 1.6 volts. So that's so it's biased about 67%, which is what you would expect for a 12AX7, and we are seeing 34 volts RMS out, and that gives us a gain of about 67. What I'll do, I'll just pop the gain up a bit, and you can watch the scope. You can see the saturation appear in the bottom, the negative peaks, and then the clipping starting to creep in at more or less the same time. So even though this isn't center biased from a DC standpoint, the distortion will be more or less symmetrical when you're biased to 66, 67%. Okay, anyway, that's the first tube. This is the rig. Let's move on. 216, let's say. That is giving us a bias point of about 68%, slightly colder. Seeing 1.5 on the cathode. And our gain for this tube is 64. Yeah, it's about 64. Okay, so we've seen gains of 66 and 64 from this small batch of four tubes. So that's a variation of about 1.5%. Not bad. Now, we're going to try different types. Let's stick in a 5751 in the circuit. This is where things get interesting, because we're using a different tube type. Ideally, you would use different circuit values for a different tube type, but we're doing what you might do and sticking in a different tube type into a circuit designed for a 12AX7. And what we're going to see is the tube bias up to a different point, and we're going to see a correspondingly different distortion characteristic. What's important to remember is that is not the characteristic of a 5751, for example. This is the characteristic of a 5751 in this circuit. So don't fall into the trap of thinking a tube has a certain sound just because of its behavior in a circuit that it wasn't designed for. Anyway, okay, look at where this is biasing up. That's a bias of about 61%. And now we're seeing 1.8 volts on the cathode. All right. Now let's watch it hit the wall and see what happens. Notice that we see the saturation on the negative peaks much earlier than we see the clipping on the positive peaks. That's the 5751. Oh, yeah, the gain for the 5751 is about 54 in this circuit. The 12AX7 was 67. 5751 gain is 54 in this circuit. So lower as expected. Now we're going to try a 12AT7, an ECC 81, 178, 179, biasing up harder at about 57%, seeing 2.1 volts on the cathode. And there's our output, 38 volts RMS roughly. So we're seeing a gain of 35, this tube in this circuit. And looking at the distortion characteristic, as we might expect, yeah, much earlier saturation of the bottom of the waveform before the clipping creeps in at the top. Exactly what you'd expect for a tube that's biased out of its optimum range. Next, we're going to stick in one that gets often tried to reduce the gain in an input stage. Is a 12AY7. There is that plate voltage settling in at about 169. So hotter still, it's biasing up to 53%. So you can see that these circuit values are putting a 12AY7 close to a 50% DC center bias on the plate voltage. 2.2 volts on the cathode, and an audio gain of 32 versus 35 for the 12AT7. All right. Oh, let's watch it hit the wall, just for fun. Whoa. Yeah. Much more saturation on the negative peaks before the clipping at the top. All right, you're getting the picture. Now we're stuck in an ECC82, which is a 12AU7, the lowest gain tube of this group. And look at how this is biasing up. Super hot. You would never design, you'd never give a 100K plate resistor to a 12AU7 if you were designing for that tube. It needs a much smaller plate load because its own plate resistance is much lower. Yeah, look at that, 98 volts. So that is biasing up super hot at 32% the plate voltage, and a gain of about 16 and 3.2 volts on the cathode. This is the exact same circuit that gave us 1.6 volts on the cathode in with the 12AX7. All right, moving on to the last tube set in this sequence. I've got a series of old 12AX7s here, various countries, various vintages, and we'll look at the variation there. Okay, now we're looking at the Softe. There's a plate voltage of about 208. So that's about 67% bias, 1.5 volts on the cathode. The gain in this circuit is 54, so a little bit lower than the Mullard we just looked at. And again, boom, 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 fairly symmetrical saturation and clipping. Now we're going to try a Sylvania 12AX7. It was made in India, so probably in the early 80s, I'm guessing. This is the plate voltage settling in around 215. Again, 67% bias, 1.5 volts on the cathode, a gain of 59. So still not as high as a fresh tube, but getting up there. And again, we see what we expect to see, saturation, the negative peaks, just before the clipping on the positive peaks. This is the first of two American-made 12AX7s from about 1960, 1961, and this will give us a sense of what sort of variation we see between two old tubes. Anyway, here's this thing biasing up, 217 on the plate, 1.4 volts on the cathode. So this is a little colder bias, 70% on this, and a gain of 59, which was the same gain that we saw in the Indian Sylvania. Okay, now we're going to try the second 12AX7 from that same batch, early 60s vintage, American made. I'm not sure which factory. This is a final tube, you'll be glad to hear. 220, so that is again 70%, again 1.4 volts on the cathode, and this one has a gain of 57. So the same gain variation in this circuit as we saw between the four current JJ tubes. Oh, well, let's watch this thing hit the wall just for fun. Same thing we saw before, fairly symmetrical clipping and saturation that we've seen on virtually all the other 12AX7s we tested. Okay, just to summarize again, let's look at the takeaways for this whole video. Number one, it's essential to always work with someone else when you're tube rolling. I know it complicates things and it seems like a pain, but otherwise you're really just wasting time. Number two, remember that the different tube types are not just plug-in gain blocks. They have different characteristics. They will bias up differently in a circuit that they're not designed for, which means that they are going to distort in different ways. That's not the tube type. It's that tube type in that circuit. Number 3, keep in mind that some circuits like cathode followers and phase inverters run the cathodes at a much higher voltage than the filament. This can stress some tube types depending on how high the B plus is in your amp. So it's a good idea to check the data sheet for the tube that you're plugging into that socket and look at the schematic and see what the voltage is on those points, or measure it. Number 4, it's a good idea to keep an open mind, because we get inundated with misinformation about which tubes are better than others, and this can contaminate our findings. If you keep an open mind and work with someone else, you might be surprised that the tubes you like are much more accessible and much less expensive than the ones you thought you wanted. And along the same lines, number 5, be careful not to draw broad conclusions from the tests that you do. So just keep in mind that what you want to conclude is that you like that particular tube at this time in that circuit, and leave it at that. Don't jump to conclusions. Well, I hope that was worthwhile. That was a preamp tube rolling, and we're going to do a power amp tube rolling video later. But this is the one that's most relevant to people. If you like it, please do all the clicky things that you need to do, or ask questions, make comments. That's helpful. It just lets me know that you like these videos, you like this content, and you'd like me to do some more when I can get around to it. For now, this is Rob from Auburn Amps, wishing you a day full of music.